Section 2.5, Quadratic Equations. Our goal of this section is to solve equations of the form ax squared plus bx plus c equals 0. Now the first way that we can solve these, and generally considered the most straightforward, is factoring. If we can factor this, in example 1, x squared plus x minus 6 equals 0. If we can factor the expression on the left-hand side, as long as we are in the form of quadratic equals 0, then this will help us quite a bit. So this will factor as x plus 3 and x minus 2. Okay, x plus 3 times x minus 2 equals 0. Now we will appeal to the zero product property. The zero product property, let's just call it the prop. Zero product property says that if a times b equals 0, then a equals 0 or b equals 0. And you might think through a couple of examples. Any two numbers that you can find that multiply to be 0, one of those numbers in that pair is going to be 0. So this means that we have two equations. X plus 3 equals 0, or x minus 2 equals 0. There we go. Which means x equals negative 3, or x equals positive 2. And those are our two solutions to that equation. All right, example 2. Solve this quadratic equation by factoring. X squared plus 8x plus 15 equals 0. First, it is in the form of equals 0, so that's good. Now we want numbers that multiply to be 15 and add to be 8, which will be 5 and 3. So this will factor as x plus 5 quantity times x plus 3 equals 0. The zero product property says that x plus 5 equals 0, or x plus 3 equals 0, which means that x equals negative 5, or x equals negative 3. And there are two solutions. All right. Solve the difference of squares equation using the zero product property. Again, we're going to factor this, and it is two perfect squares, a difference of two perfect squares. So this will factor as x plus 3 times x minus 3 equals 0. And then x plus 3 equals 0, or x minus 3 equals 0, which means x equals negative 3, or x equals positive 3. Right, example 4, use grouping to factor and solve this quadratic equation. So first we want constants, numbers that multiply to be 36, that add to be 15. Okay, and running down our list, and I do encourage you to write a list and go down the list if you don't see what it is fairly quickly. 1 and 36, 2 and 18, 3 and 12. 3 and 12 is it. All right, so this was going to, the way we're going to write this is 4x squared plus 3x plus 12x plus 9 equals 0. Notice that if we went in reverse, if we combine these two, we would get that 15x. We're splitting that into two pieces. Next, we're going to group the first two, and it appears that an x is a common factor there, so we'll take that out. That'll be 4x plus 3. Now the second pair appears that 3 is a common factor, so we'll factor out a 3 there, which will leave us with 4x plus 3. Now we have a common factor of 4x plus 3, so that will be taking that out. 4x plus 3 quantity times x plus 3 quantity. All right, so that means 4x plus 3 equals 0, or x plus 3 equals 0, meaning x is negative 3/4, or x equals negative 3. And there are two solutions. Now you might notice I haven't checked any of these. The zero product property makes things work out very nicely. nothing can actually go wrong when we're working with a quadratic in this case, except possibly that it doesn't factor. Okay, so we'll see what happens in a minute when we come up with something like that. All right, example 5, solve this equation by factoring. All right, the first thing I'm going to do is look for a greatest common factor, and in this case, I'm going to factor out a negative x. A negative x, which will leave us with a 3x squared plus 5x plus 2 equals 0. And now I'm going to factor the inner function there. I'm going to factor that by the grouping. Okay, so that will be, I need numbers that multiply to be 6 and add to be 5, so that would be 2 and 3. 2 and 3. So let's go ahead and write this negative x out here. I'm going to put brackets so this doesn't get as confusing. 3x squared plus 2x plus 3x plus 2 equals 0. Grouping the first two, and x is in common, so I'll leave this negative x here. Take an x out of those first two terms, so that'll leave a 3x plus 2. Now the second two, all right, I'm going to take out a positive 1 because those two are relatively prime. So that means this is going to factor as negative x times 3x plus 2 times x plus 1. Okay, so we have either negative x equals 0, 3x plus 2 equals 0, or x plus 1 equals 0, which leads us to x equals 0 as one solution, x equals negative 2/3 as a solution, and x is negative 1. Now, if you notice, all of these quadratics have had at least 2 solutions, or at most 2 really is how it works. Here I have 2 solutions to this equation. This previous one, x squared minus 9, I have 2 solutions. So why did this one have 3? And I think that's a valid question. Why does this one have 3? Well, it comes from the fact that our highest exponent in this expression is a cubed. So we can have at most 3 solutions. That's how that works. The degree tells you the largest number of solutions you could possibly, the maximum number of solutions. Right, for number 6, we'll use a different property. Use the square root property, meaning we will take the square root of both sides of this equation. So I'm going to go ahead and write x squared equals 8. If we take the square root of both sides, this gives us x equals, and the square root of 8, square root of 8 is 2 root 2. Okay, so if we consider a factor tree of all things, this is the square root of 2 squared times 2, which is 2 square root of 2. Now, something we need to remember is when we take the square root, there are actually 2 solutions. This is going to be a plus or minus 2 root 2. So our solutions are x equals negative 2 root 2 and 2 root 2. If we introduce a square root, we have to consider the 2 solutions that we have there. All right, number 7, solve this quadratic equation. Because there's no x term, we have an x squared term and constants, the square root property comes in very handy. So let's rearrange this so that it has equivalent solutions. 4x squared equals 6, dividing by 4. We have x squared equals 3 over 2. Taking the square root. Okay, so we have x equals plus or minus square root of 3 over 2. Now the square root of 3, the square root of 2, I'm going to go ahead and rationalize that. This will be the square root of 6 over 2. Of course, the plus or minus there. So our solutions are negative root 6 over 2 and positive root 6 over 2. Next, solve this by completing the square. Slightly different tactic here. When we deal with completing the square, and sometimes this will work when things don't factor, which, as you could see, those last two, those wouldn't have factored because our solutions are not integer answers. Okay, so to complete the square, what we want is to have this in the form x squared minus 3x plus something equals 5 plus something. So I'm going to move my constant term to the right side, and I'm going to add something to both sides. Now, how I find what I'm going to add to both sides is going to be from this term right here. We actually want this to factor to be a perfect square trinomial. So we'll start with negative 3, and we'll divide by 2. So that'd be negative 3 over 2. And then squaring that would be 9 over 4. 9/4 is what we're going to put in this blank that I've drawn here. Okay, well, that will cause the left-hand side to factor as x minus 3 over 2 squared. That is coming from this right here. These are always going to match up the way that this strategy works. All right, that equals, and that will be 20/4, so that will be 29 over 4. Now, it's a square root equation, so I'll take the square root of both sides. Take my square root of both sides so that my equation is x minus 3 over 2 equals plus or minus root 29 over 2. Now, adding 3 over 2 to both sides, my solutions are going to be x equals 3 over 2 plus root 29 over 2, and 3 over 2, 3 halves, minus root 29 over 2, which I could combine those into one fraction. But there are my solutions. In fact, let's go ahead and write this as one fraction. Okay, 3 over 2, 3 minus root 29 over 2. I want to look back at this in a second and notice what form that's in. All right, number 9. I actually want to solve this one two different ways just to show you that the two methods will give us the right solution. But let's go ahead and do completing the square first. So we'll get this in the form x squared plus 5x plus something equals negative 1 plus something. All right, now I'm going to take 5 divided by 2, so that would be 5 over 2. And squaring it would be 25 over 4. So I'm going to add 25 over 4 to both sides. Now, this left-hand side will factor as x plus 5 over 2 squared. Okay, equals, and that will be 4 minus 4 over 4, so this will be 21 over 4. Now we'll take the square root of both sides. So x plus 5 over 2 equals plus or minus root 21 over 2. Adding or subtracting 5 over 2 from both sides, we have our solutions of negative 5 over 2. And we're going to have our same denominator. May as well combine that. Plus root 21, or negative 5 minus root 21 over 2. Okay. Next, actually, I'll come back to that in a second. All right, next we have the quadratic formula. We want to use this to solve x squared plus x plus 2 equals 0. The quadratic formula says that if ax squared plus bx plus c equals 0, then x equals negative b plus or minus the square root of b squared minus 4ac all divided by 2a. Okay, and that is the quadratic formula. So let's identify the a, b, and c values. All right, so a for this equation is 1, the coefficient of the x squared term. B is the coefficient of the x term, so that'll be 1. And our c value is our constant, so this will be 2, because it is in the form equals 0. All right, so x equals negative b, that would be negative 1, plus or minus the square root of b squared minus 4ac, all divided by 2a. That will be negative 1 plus or minus the square root of something over 2. And that would be 1 minus 8, that is negative 7. So our solutions are actually going to be in this form, negative 1 plus or minus I root 7 over 2. And I'd like to write this as 2 solutions, and actually I'll break this up into 2 fractions, just commonly what you do when you have imaginary solutions. Negative 1/2 plus I root 7 over 2, or root 7 over 2I, and negative 1/2 minus I root 7 over 2. Okay, so you might notice that the quadratic formula ends up with solutions that look a lot like completing the square. We've got our square root in there, it's all in one fraction, and that is a good point to make, to see that there is something going on there. The quadratic formula is actually proven by using completing the square. So they will actually give you equivalent solutions. So I'm going to go ahead and use this space right here, and I'm going to revisit number 9. All right, so I'm going to call this 9b, x squared plus 5x plus 1 equals 0. Well, my a value, my b and my c value, a is 1, my x squared term, my b is 5, that's the coefficient of the x term, and my constant is 1. So x equals negative b plus or minus the square root of, let's go ahead and fill this in, b squared minus 4ac all over 2a. All right, so negative 5 plus or minus the square root of something over 2. So 25 is 5 squared, minus 4 is 21, which ought to look slightly familiar from our number 9 solutions. So completing the square and the quadratic formula do, in fact, they will give you the same solutions. So oftentimes it's up to you. Try factoring. Factoring is often the easiest or the most straightforward way to go about things. But if your equation does not factor, or your expression doesn't factor there, then the quadratic formula or completing the square are our next move. All right, example 11. Use the discriminant to find the nature of the solutions of the following quadratic equations. Okay, the discriminant is a part of our quadratic formula. b squared minus 4ac, that part of our quadratic formula, the radicand in that, tells us how many solutions we have, and that's what it means by the nature of the solutions. So if b squared minus 4ac, if that is greater than 0, okay, we have 2 real solutions. If b squared minus 4ac is equal to 0, we have 1 real solution. And if b squared minus 4ac is less than 0, we have no real solutions. Now you might notice I'm specifically saying real solutions here because we can have complex solutions or imaginary solutions. So that could very well happen. And in fact, we always have 2 solutions. It might be our double root when it's equal to 0, where we have 1 solution that actually, in some sense, occurs twice. We might have 2 real solutions where they're 2 distinct values. And we might have none where we have some complex solutions. But in any case, a quadratic will always have two solutions once we consider complex solutions. All right, so for part A, we're going to calculate b squared minus 4ac. So 4 squared minus 4ac. That is equal to 16 minus 16. That is 0. So we have one real solution. All right, part B. We have our A, our B, and our C there. They're all equal to 0, so that's a good thing. So 14 squared, that's our B, minus 4 times 8 times 3. All right, 196 minus is 100. Discriminant's 100. That is greater than 0. So we have two real solutions. All right. Part C. Again, I'm going to go ahead and label A, B, and C. This will be negative 5 squared. That's our B value. Minus 4AC. All right. This is going to be positive. Plus 24. It's going to be 49. So we have two real solutions there. And then part D, that'll fit right in here. B squared, negative 10 squared minus 4AC. That's 100 minus, is that 180? Yep, 180. So that is going to be negative 80, which means we have no real solutions. That equation would have two complex solutions. All right, last example for this section. Find the length of the missing side of the right triangle. All right, so we will appeal to the Pythagorean Theorem because we have a right triangle. We'll just actually use A for our A side. Our B is the other leg, so that is 4 squared. And our hypotenuse, the longer side, 12 squared. So A squared plus 16 equals 144. Subtracting 16 from both sides, we get A squared equals, I believe, 128. 128. Meaning A is equal to plus or minus the square root of 128. Now, because we are talking about the legs of a right triangle, we can disregard the plus or minus, and it's only going to be a positive solution. So A equals the square root of 128. All right, now let's see, that's 64 times 2 times 2. So that would be 8 root 2. And we don't have units, but that is going to be the length of that side of the triangle. All right, that brings us to the end of this section on the quadratic, on finding the solutions of quadratic equations. Remember, factoring is our go-to. Then we have the square root method. Okay, then we have completing the square, and then last, the quadratic formula. And the quadratic formula works every time, but it's always a good idea to check the discriminant and see how many solutions you're going to have, and if they are integer solutions, that's always good. Okay, that's the end of the section.